Hi everyone, in this series of videos we're going to take an introductory look at acid-base titrations. If you haven't done so already, can you please pause this video and watch the video that I've linked here. It should also come up as a pop-up in this video right now. So please pause this video and take a look. It provides a nice overview of the titration procedure. So what is a titration? A titration is a form of volumetric analysis. During a titration, the number of moles of a solute in a sample, which we call the analyte, is determined by adding a sufficient volume of another solution of known concentration, which we call the titrant, to just produce a complete reaction. So we don't want to add an insufficient amount or an excess amount of titrant. We want to add the exact amount where the titrant and the analyte are going to completely react. Titration is an important analytical procedure that we can use to determine the concentration, molar mass, or percent purity of our analyte. In order to perform a titration, we must meet three criteria. So first of all, we can only have one reaction occurring between the solutes in the two solutions. So we don't want multiple reactions going on. We want to be able to directly relate the number of moles of our titrant to the number of moles of our analyte, and that's going to not work very well if the titrant and analyte are participating in multiple reactions. Okay, secondly, we need the reaction to go to completion. That means for an acid and base titration, we need one of the acids or bases to be strong. Okay, both of them can be strong, but one of them definitely needs to be strong in order to drive the reaction to completion. Finally, we need a way of signaling the point at which the completion has been achieved in the reaction vessel. So that point is called the equivalence point, also called the stoichiometric point. And so for an acid-base titration, that equivalence point occurs when the total moles of hydronium ions from the acid is equal to the total moles of hydroxide from the base.